Hi, this is Tim from Tiger Astronomy, and following on from my little progress update video, was it yesterday or the day before? I can't remember. I'm quite a lot further forward now today, so I thought I'd just make a quick update to show you. And okay, so in the hardware over here, we have the this is the rotator motor here. This is the rotator electronics. This is the shutter motor. And this is the shutter electronics over here, just on the edge of the screen. And so on my screen recording now, I'm going to just use my little test harness to new up the code as I did before. Okay, and at that point I'm just pausing to see we've got some diagnostics coming out in PowerShell, and I haven't switched to PowerShell yet, so let me just switch over and show you what I've done. So there we are with some diagnostics coming out, and on my other screen over here I've got a program called Log Fusion, which is also catching diagnostic output, but this will have quite a lot more detail in it. So too much detail on the console screen is bad because you can't see what you're doing, but you do want that detail sometimes, so it's over here on this other screen. So back to the right screen, and okay, so what can we do? The first thing is I'm going to just press the reset button on both of the hardware modules here, just to put them back in a known state so I know where I am. So there we go, and that's rebooted. So now I can $device.open, we can open the communications channel, and as you can see it's immediately requested the rotator status and got that. The link state is basically booting up and trying to detect the shutter, and while we're waiting for that to happen, we'll just show you what's going on in Log Fusion, because there's quite a lot more information coming out on this screen. And bang! So we now have the link established, and we've gone into shutter closed state there. So on the right screen on PowerShell that looks like this. So here was the status: closed sensor active is true, and position 0, which is fully closed. So where do we go from there? Right, so what we can do now that we couldn't do yesterday is we can go device.slew to azimuth 90 degrees, say 90 degrees, and away we go. And you should be able to see here my little sticky tabs falling off, but the rotator motor is going. And over here on the screen nothing much is happening, but on Log Fusion you should be able to see there's loads of stuff coming through here, and these on next lines here are telling you the current encoder position. Bang, and we've got there. And on the right screen here we can see that the rotator status arrived, which means the movement's stopped. So at home is false. Our current azimuth is now 13,770. That's motor steps out of a possible 55,080. So that should be roughly a quarter of the way there because it was 90 degrees. Okay, so the other thing we can do is we've got shutter sensor state, and that's currently closed. So we can also, because the shutter's online, the link is online, we can say device.open shutter, open shutter, like that. And okay, over here you can see the shutter motor is now moving. I'm going to manually pull the close sensor off of the magnet because I don't have a real dome here. I'm having to simulate this manually. And over on the other screen here we've got Log Fusion spewing out, and now it's telling us shutter position updates here. So shutter position on next 22,000. It goes up to about 44,000 I think for a fully open shutter. So we're up to 28 at the moment. 33, 34. So over on the right screen here, whilst we're waiting for that to get there, you can see that the shutter link state online comes through every few seconds. and that constantly reassures the rotator that its link to the shutter is still active. And if that should fail to arrive, then the link is considered down and the XB is rebooted and everything's reconfigured dynamically. So here the shutter got to the end of travel. We're at position 46,000. The closed sensor is no longer active. The open sensor isn't active either because I currently don't have a sensor attached for that. But if we look at the shutter sensor state, we are now open. So we could, in theory, device.close shutter, and while it's doing that, device.slew to azimuth 0, and now we go, there we go, both units are working together. And in the left screen we can see all the diagnostics coming out. We're getting encoder ticks, link state messages. We should be getting shutter messages as well coming through, though I can't see any at the moment, but that will be working. Sometimes the screen update's a bit slow. There we go, we got rotator status. Now we're seeing shutter positions coming through. Currently at 17,000, 12,000, and 8,000. Back to the PowerShell screen, and I'm going to throw the close sensor on, and I found a bug there. Now what's happened there is that one of the data streams has caused an exception, and that's caused the serial port to close, and that has upset things. So as you can see, it's not finished by a long way yet, but I think you can see significant progress from the previous video. So this is the difficult part of the driver now, getting all the data streams in the right format and going to the right place, and having all the state machines do the right things in response to the right inputs and the commands. And once that's done and tested, then the ASCOM driver just actually is a minimal amount of code on top of that, and it will be really, really quick. And then the next major task after that is to add the local server, which I have a template for that, which will allow me to do it quite quickly, and then a bit of user interface work so that we have a status display of what's going on. So hopefully sometime in the coming week we'll have a pre-release build for people to test. So that's it. I've been Tim from Tigret Astronomy. Thanks for watching, and goodbye.